We'll discuss some of the numericals. Numerical number 8.3. Suppose there exists a planet that went around the sun twice as fast as that of the earth. So if you consider the angular speed of the earth around the sun as omega, then the planet will have the angular speed as omega prime. What would be its original rather orbital size as compared to that of the orbit of the earth? Now see, first of all we consider the thing for the earth, okay, and we consider mass of the earth as me and mass of the sun as ms, and we consider the system of earth and sun. Okay, when earth is moving around the sun, then centripetal force is providing required gravitational force. So centripetal force on the earth as earth is moving around the sun, try to understand. Earth is moving around the sun, then the centripetal force on the earth, if the distance between the sun and the earth is r, then it can be written as me v square upon r, that is the centripetal force, okay, and gravitational force between the earth sun system is gme ms upon r square, where me is the mass of earth, ms is the mass of the sun. Now we consider v square as a subject of formula. Make v square as a subject of the formula, okay. So then here me will be cancelled out, okay. So v square can be written as gms upon r1, r also can be cancelled out, okay. Now as you know, v is equal to r omega, so instead of this v we write r omega, so then it becomes r square omega square, and omega square is made subject of formula, so it becomes gms upon r cube. And similarly for the planet we can write omega prime square is equal to gms upon r prime cube, where r prime is the distance between the planet and the sun, okay. Now we just take the ratio of omega square upon omega prime square, then it will become r prime upon r whole raised to cube. You can understand this very easily. Now omega prime is equal to 2 omega. It is given to us that it has the relationship as omega prime is equal to 2 times omega, okay. So instead of this omega prime we write 2 omega, then omega will be cancelled out and square of it will remain, okay, or we can say omega upon 2 omega whole square. So this will be cancelled out, we will have 1 upon 2 whole square, and it will be on right hand side as it is r prime upon r whole raised to cube. Now r prime upon r is equal to 1 upon 4 you can get, okay. So r prime will be equal to, you can make r prime as subject of formula, or we can say r prime cube upon r cube is equal to 1 upon 4. So r prime is equal to r into 1 upon 4 and its cube root. So it is a cube root of 1 upon 4, and if you find it with the help of log table or calculator, then r into 1 upon 1.588 you will get, and 1 upon 1.588 will result into 0.63. r will remain as it is. So the radius of the planet, or we can say the distance of the planet whose orbital time period is 2 omega, is 0.63 times the distance of the earth, okay. Now we talk about the new numerical, that is 8.4. In one of the satellite of Jupiter has an orbital period of 1.769 days and the radius of the orbit is 4.22 10 raised to 8 meter, show that mass of the Jupiter is about 1000th that of the Sun. Now see, orbital period of Jupiter is given, and that orbital period is 1.769 days. Now 1 day is 24 hours and 1 hour is having 3600 seconds, so it is converted into second. This is very easy. 1.769 into 24 into 3600, so you will get 1.528 into 10 raised to 5 seconds. Now radius of the satellite, it is given 4.22 10 to the power 8 meter. G, universal constant, is known to us. Okay, mass of Sun is known to us, or it will be given if it is asked, 2 into 10 raised to 30 kg. We consider that mass of the Jupiter is mj. Okay, now centripetal force on the satellite by the Jupiter. Okay, the satellite is moving around the Jupiter. It is a Jupiter satellite. See, one of the satellite of Jupiter. So it is a satellite of Jupiter, and we consider the system of the satellite of Jupiter and Jupiter. So say for example, this is Jupiter, and around it, its satellite is moving, whose mass is m. Mass of Jupiter is mj. Okay, so this is moving around the Jupiter. So centripetal force on this satellite of mass m is mv square upon r, and the system is of Jupiter and its satellite. So the attractive force according to the universal law of gravitation is g mj m upon r square. Make v square as a subject of formula as we have done earlier. Okay, so we will have v square is equal to g mj upon r. V is equal to r omega. Okay, this we have done earlier. Okay, so r square omega square is equal to g mj upon r, and make omega square as a subject of formula. This r square will come in the denominator, so it becomes g mj upon r cube, and as you know, omega is equal to 2 pi upon t. So instead of this omega, we write 2 pi upon t, and square of it will give you 4 pi square upon t square. Okay, so we can make mj now as a subject of formula. Okay, this mj can be made as subject of formula. Okay, and we will get 4 pi square r cube upon t square into g. All the values we have already calculated. Okay, r is there, it is given to us. Okay, then t is already calculated, 1.528 into 10 raised to 5 the square, and simplify this, you will get round about approximately 2 into 10 raised to 27 kg. Now mass of Jupiter upon mass of Sun, if you take, then that ratio will give you 1 upon 1000. 1 upon 1000. So we can say mj is equal to ms upon 1000, that is mass of Jupiter is 1000th part of mass of the Sun. Okay. Now we talk about the numerical number 8.5. Let us assume that our galaxy consists of 2.5 into 10 raised to 11 stars. So there are 2.5 into 10 raised to 11 stars. Okay, number of stars we can say in a galaxy is 2.5 into 10 raised to 11. And each star is having one solar mass. Now mass of the Sun is known to us. Mass of Sun is 2 into 10 raised to 30 kg. So total mass of the galaxy, try to understand. Total mass of all the stars in the galaxy will be the product of these two, that is 2.5 into 2, that becomes 5 into 10 raised to 41. Okay, so this data is first taken into consideration. Total mass of the stars in galaxy is 5 into 10 raised to 41 kg. Okay, How long will a star at a distance 50,000 light year from the galactic center take to complete one revolution? Take the diameter of the Milky Way to be 10 to the power 5 light year. Okay. Now see, orbital radius of each star, that will be equal to 50,000 light year. Okay, it is given. So light year is known to us, 1 light year is 9.46 10 to the power 15 meters. So that radius will be in meter to be 50,000 into 9.46 into 10 to the power 15 meter. That will be the radius in meter. Now again similar procedure, centripetal force. Okay, star is revolving around the galactic center. The center of the galaxy, try to understand, center of the galaxy will have the mass which is equivalent to the mass which we have calculated, that of the whole galaxy. Okay, and that mass we have calculated here. Here it is 5 into 10 to the power 41 kg. That much mass must be there at the center of the galaxy. So center of the galaxy, this is the center of the galaxy which must have the total mass of all the stars in the galaxy, otherwise those stars will not revolve around the galactic center. Okay, so that black hole which is situated at the galactic center must have the mass 5 into 10 raised to 41 kg. Okay, and that mass is taken as capital M. So one star which is at what distance? 50,000 light year. This is the distance, and this is the star whose mass is M. Then this is revolving around the galactic center. Okay, so the centripetal force will be mv square upon r, that will be equal to g mass of galactic center, that is capital M, into the mass of the star which is revolving, gm into small m upon r square. Okay, so v square you can get easily, we have done this, v is equal to r, omega is known to us. Okay, omega can be made as subject of formula, omega is 2 pi upon t. Okay, all these things we have done in the previous example. Okay, so t square can be made as a subject of formula, 4 pi square r cube upon gm. Okay, so t is equal to under root we can take. Okay, and place all the values. G is known to us, R is 50,000 light years, we have converted into meter. Okay, mass of the galaxy 5, rather galactic center. Okay, that is 5 into 10 raised to 41, and simplify, you will get this. Power has to be adjusted into even number and take the square root. So power will become half. It becomes 10 to the power 14, and square root of this will result in 111.86. And if you want to convert it into year, then we have to divide this seconds, okay, by the number of seconds in 1 year, and that is 365 days 24 hours, and 1 hour is 3600 seconds. So this will result in 3.547 into 10 raised to 8 years. Okay, about 3.55 into 10 raised to 8 years. Now example number 8.12, others are question answers that you can prepare on your own. A rocket is fired from the earth towards the sun. At what distance from the earth's center is the gravitational force on the rocket is 0. Mass of the sun is 2 into 10 raised to 30 kg. Mass of the earth is 6 into 10 raised to 24 kg. Neglect the effect of other planets. Orbital radius of the earth is 1.5 to 10 raised to 11 meter. Now see, a rocket is sent from the earth, and this is the point where the gravitational force is equal in magnitude, opposite in direction, and it becomes 0. So this distance we have considered as distance x from the center of the earth. Okay, so this is distance x. Total distance between the earth and the sun is r, which is nothing but 1.5 into 10 raised to 11 meters. So this distance where the force becomes 0 from the sun will be r minus x, because this distance we have considered as x. Okay. Mass of the satellite is m, or mass of the rocket is m, mass of the earth is me, ms is the mass of the sun. Now both the forces here at this point, which is situated at distance x, must be equal in magnitude. So force on this rocket by the earth must be equal to force on the rocket by the sun, and we are comparing these two forces. So GMEM upon x square is equal to GMSM upon r minus x. Now G will be cancelled out, this M will be cancelled out. Okay, so you will have MS upon NE. Okay, MS upon ME. And this side it will be R minus X the whole square upon X. Okay, so you can easily simplify now. Place the values of mass of the sun and mass of the earth. Okay, so these are the values which are kept. You get 10 to the power 6 upon 3. Take the square root. Okay, so r minus x upon x is equal to 1000 upon root 3. Okay, now root 3 is multiplied, cross multiplication is taken. Okay, so root 3r minus root 3x is equal to 1000x. Okay, now root 3x is neglected relative to 1000x. So just we are removing this, or rather we are not taking into consideration this part, it is root 3x, because it is very small. Okay, if you just take it on the other side and add in 1000x, then it is not giving you the significant figure or very big value. Okay, so just neglecting this very small value of root 3x. So now root 3r is equal to 1000x, so x will be equal to root 3 is 1.73. Okay, r is given, that is 1.5 10 to the power 11 divided by 1000. So x will be about 2.6 into 10 to the power 5 kilometers. Okay, thank you. Watch this 2-3 times and write all the numericals in the notebook. Okay, thank you very much.